started. So, my name is Ryan Tischer. I'm a Google Cloud engineer based out of the Milwaukee area here. And like maybe a quick secret, just maybe a level set, just so you sort of understand my background a little bit, is that I'm not a video game developer. I'm a gamer myself, but don't write them. However, I have written a bunch of other pieces of software, wrote a book about writing software, and do a lot of work in big data analytics. So hopefully we can try to find some middle ground here in terms of these different skill sets. The other thing that I would share with you is, well, the secret, I guess, is that I have a number of giveaways that I have to give away during this presentation over the next 45 minutes or something, but I have no plan to do that. Okay, so right now my strategy is to reward for things like good questions or comments, even compliments for work as well. So I could be bribed. So keep that in mind. Now, the game for you guys though is like, how many things did I bring, right? Like, I'll tell you my computer bag is full, but how big a bag? I don't know. That's the game here. Okay. Anyway. So the talk today is about analytics in games. I do realize that the marketing folks put a lot more verbiage around the title of this thing, but the net is that's what we're talking about. But before I get into that, I wanted to discuss a little bit about what Google Cloud Compute Platform is and really some of the really awesome things that we do there. So, in a nutshell, right? Google GCP, Google Cloud Compute Platform, is a stack of, we'll call them, cloud-based services, right? So, at the top of the stack, we have things like G Suite, Android, Chrome browser, things like that. We also feature things like Apogee from an API layer, API management layer, to Firebase. Had some really good conversations around Firebase, which is a mobile application platform for making mobile software a little bit easier. And then finally getting into, what I would consider like more traditional cloud-based services. So, this is things like infrastructure as a service and platform as a service. We have Kubernetes as a service. Or managed Kubernetes is the way I should describe that. So, the full, again, really the concept here is that it's a full-featured cloud stack that is, industry leading, right, world class, and probably similar to any other cloud platforms that you may use today. The way that you really sort of want to think about GCP though is at what we consider, or the industry considers, Google scale, right? And what that means to you is, when you look at Google, this is billions of users on a daily basis. What do we say here? 6 billion hours of video watched monthly, things like this, right? So Google scale, very big, very fast, very powerful. And when you sort of think about that, we had to come up with a bunch of innovation to do that, do things a little bit differently, right? So do things differently from an operational standpoint, do things differently from a security, availability, performance standpoint, things like this, right? That's how we get to operate at this scale. And when you think about GCP, understand that it's a first-class citizen as part of this network, right? So when you start to consume services from GCP, understand that you're part of this, right? You're part of this scale, you're part of this innovation, this performance, this availability, this security, this operational efficiencies that you see within the search bar every time you go to Google. I should mention you can stop me anytime with questions, and again you'll be rewarded if you're late. So right, remember, no plan. So then you sort of take that and you start thinking about it from a geographic standpoint. And the key message here is that we have a presence in most of the world, or at least close to most places in the world. So this is just a picture of where Google has presence and the network that connects these things. So understand that this is a private network. This isn't the internet. We have our own cable. In this case, you're looking at either cable that we have already or cable that's planned to be put down that connects all these things. And again, very, very fast, very, very high performance, and very available. So then, so then the question sort of comes up, and when you start thinking about that Google scale, you start thinking about the network. What does that mean to you? And these are just some like quick metrics, right? So if you were to ask me, why does Google have the best cloud service available? Or somebody asked me very directly this morning, why is Google better than AWS? I would start to talk about some of these things, like, for example, and you could go back to what I said earlier, the availability, the operational stuff, decreased outages, performance, blah, blah, blah. But then you come up with some of these more soft factors that tend to come up more in life. Like, for example, I can spin up VMs faster. I have lower latency on the network. What else do we have in here? More customizable, better I/O, better dealing with CPUs and virtualized environments and things like that. So we're just talking about GCP. I promise we'll get to the meat of this presentation at some point here. But these are some of the big advantages that we see and our customers see. And here's sort of the kicker of this is that we do this at a lower cost, right? And then you come back to what I said earlier, around that operational stuff. How do we do that? We have better operations than anybody else. We have better security than everybody else, and that cost is sort of extended into our customer base. There's actually some really good YouTube videos, believe it or not, about pricing philosophy from our standpoint, and how we are committed to continually to make and provide better services, but then drive the cost down on those exact same services. So then what's available, right? We're going to talk a little bit more about some of these things in depth, but again, this is a full stack cloud. So you've got things like infrastructure as a service, very basic. You load an operating system, you manage it from there. Moving from there, we have things like managed Kubernetes service as you get into container orchestration. If you're looking for a higher abstraction layer, moving up that stack and getting into PaaS, we offer that type of service as well. Very popular with game developers because they don't necessarily want to deal with all the infrastructure. They just want to focus on writing quality code and capturing the revenue associated with that. We also have things like cloud functions, similar to maybe an Amazon Lambda, for even lighter weight abstraction and lighter weight software development. And then from there, a whole host of managed services. So this is going to be everything from managed big data to machine learning APIs and things like this. And as a matter of fact, we'll cover some of these as we get further into this presentation. So I'm an engineer, so I never like putting money slides up, but there's real dollars around this commitment to building out these type of services. So if you look at what we spent in the last 3 years, it's roughly $30 billion. Okay, and this is a lot more than anybody else is spending, and we hope that we build a product that matches that spend and is something that our customers and guys like you want to write and use GCP for. So that's the end of the GCP pitch. I appreciate you sticking with me during that. The marketing guys were holding my firstborn hostage, but I didn't go through that. So, all right, good, some smiles. I know it's getting late in the day. Any questions about GCP before I move on? You'll be handsomely rewarded. Yes, sir.
There was a graph a few slides back.
Sure.
I had just seen that Google, or
Which one?
that one.
Yep.
Pokemon Go runs. What's GKE and database?
Good question. So GKE stands for Google Container Engine. Container with a K. We do that because we also have Google Compute Engine, GCE. So the big brains in Mountain View came up with the K. That's how to think about that. So it's managed containers, managed Kubernetes, actually, is the better way to say that, right? And then the data store is GCP Drive. Think of it as GCP Drive, right? So it's object-based cloud storage. Okay. So Google Home Mini or Chromecast?
What's the Google Home Mini? I guess.
Yesterday. That's what you guys need to. All right. So, so moving on to what we promised to talk about here, right? Data in games. So, I actually hesitated going down this path a little bit because I feel like this audience may already know this answer, but we'll say it out loud for clarity. But it's all about providing better player experience, right? And through that better player experience, capturing more revenue from players, okay? And as a matter of fact, we had some really good conversations with folks this morning around all of the different metrics that we can capture in a game, everything from their experience within an app store to in-game analytics, how many tries did it take to beat the boss on level 12 sort of stuff, and then changing that into a spot where you can personalize that game, or you can personalize marketing to that game, or sell personalized space to that game. There's really unlimited possibilities there, but I think the thing that's really important for us to focus in on is that it's a win-win, right? It's one of those things where the 1 + 1 is greater than 2, because what it comes down to is having a better experience for the user itself, for the gamer itself, and then in turn we have the ability to monetize that in a little better way, hopefully, in a bigger way. So then then we get into sort of how we do that, right? And I'll get into some more technical content here, and again, open for questions. But it starts with gathering data, or what we call in the data analytics world, building a data lake. So this is where we basically want to capture anything and everything associated with the user interaction, from the beginning of when they start thinking about purchasing the game, to navigate into the app store, to how much did they spend, what other games did they buy, what did they say in social media, to things that you may capture from an AdWords or DoubleClick standpoint, through Google, and then data that's going to be specific to the game itself. So again, this is going to be what moves did they make, what decisions did they choose, how much money did they spend, where did they loiter, where do they, who do they interact with, what does it look like from, you've got a social aspect to your game, so on and so forth, right? So, again, the point is that we want to capture anything and everything and build the data lake. And for a lot of folks, as a matter of fact, again, we had a conversation about this. This is where people tend to get stuck, right? We know there's value in the data, so we capture the data, and then the question is sort of what do we do with it, right? So the point is, anytime we start talking about analytics, is to ask questions of the data, right? Learn from the user's interactions, and then make that actionable information as we refer to it, right? So some of the I forget what we wrote here, but how many players made it to stage 12 sort of questions. How long did it take them? Did they buy weapons, or whatever the case is, once they get there? And then how do I sort of take that data and apply it to other users so that they may buy the same weapon, or have a better experience, or whatever the case is, right? So again, what we're doing here is we're asking questions of the data, asking interesting questions of the data, and the questions are basically unlimited, right? And this is where we see, from our standpoint, we see a lot of differentiation between our customers that are willing to think outside the box and ask some of these more interesting questions, and then ultimately capture data from that. And that gets us into this slide. So you may think I hate the way that goes. Have we done this before? Right? Is this brand new? Is this something Google just dreamed up last night? No, I just did the slides last night. But it's something that we've had success with in the past, right? And there's some pretty big names on this slide that are very proud Google users, and as a matter of fact, these are all Google Analytics users. I think the ones in it, and places where again we've been able to ask. These customers have been able to ask those interesting questions and analyze and parse out the data to get answers to. All right. I'll pause for questions. Is there any? Yes, sir. Yes, ma'am. Ladies first.
Oh, is the back end of the Google Analytics that you use for games the same as the Google Analytics you use for a website?
Sometimes, yes. So, so Google Analytics is a big term. right? So what I'm focusing on is how you do very customized, very advanced analytics within the GCP platform. Now, sometimes you can get the answers you're searching for without doing that, right? You can use easier tools or more wizard-based sort of things, but oftentimes, especially when you get into custom data, especially like stream from a game, you're going to want to drive that into more of a custom analytics solution. But the other thing about that is you'll often see them as multiple data sources. So you may, like GA360 is where I'm thinking, is my head is right here. So you may see like GA360 data get fed into some of the models we're going to talk about a bit. So Chromecast or Home Mini?
Home Mini.
Got it. Go ahead, sir.
So that list of questions, is that something we have to come up completely with our own, or like do you have like a standard set, or are you willing to like share what other people are asking, so we can get sort of the best set of questions?
So the way that, so there's always going to be like standard. There's going to be like really common questions that show up in your world, right? So. Again, I refer to a conversation we had this morning, right? We made a change to the game, and for 2 months we saw a drop, right? And then it wasn't until somebody said, "Hey, did we make the change around the same time the drop came?" "Oh, we did," right? And then they could go and then go back, right? So that's a question we would ask, right? A/B sort of things, right? I want to understand the impact of this change, and then fail fast if I have to, or double down on the change, or whatever the case is. Sometimes it's different than that. So. I'm trying to think of an example, but let's just say that you built this awesome 15 level game or something like that, but nobody gets past level 1, right? And you start making money when they get on level 3. So that's a great example where you could use analytics on what the players do, how they fight the boss, or get through the level, or figure out the puzzle, or whatever the case is. And then make a decision, well, maybe this is too hard, or we need to give more clues, or more light, or whatever the case may be, to get through that. And that's more of a question that is going to come from your intellectual property and what you understand about your product than it would be some standardized thing. So Google Home Mini or Chromecast?
I'm trying with Google Home.
You're actually making my life easier because I'm now at Google Home Mini.
Thanks.
Yes, sir.
So I run a cross-platform MMORPG. We've dealt with various and sundry analytic solutions, Flurry. We've built our own stuff on Graphite and various and sundry others. And when I've looked at Google Analytics in the past, it seemed pretty platform specific. Like you guys had solutions for Android, obviously, you had some solutions for iOS, but I've got PC stuff as well.
Right.
Is there a way to integrate this across everything? And I mean, I'm including like console and anything else.
Absolutely, yeah, absolutely. So, here's how I would try to prove that point to you: is that if you're a gaming company or you're a retail company or a financial institution, I'm going to apply the exact same frameworks, the exact same tools to answer that question. To help you analyze that data, because it's really all about getting the data in the right format and then doing ETL on it from there. And as a matter of fact, we'll walk through some of those pipelines, which may make more sense of that.
Sure.
Okay, I got some for you.
I'm trying to use Firebase for our mobile app now. Is that
Awesome.
based on this too? But it seems like it's not quite robust for, like, it's not getting twin stream data or anything like that. Something we can do in there, or is that something we should leverage out of the other?
We're being recorded, I have to actually I'll price it too much. So the answer is yes, right? The answer is we can get the data out of what you develop in Firebase, but it may not be as streamlined as you would expect it to be in Firebase. And the recording stops in like half an hour. We'll get more information on that. Yes, sir.
Okay. I apologize because I very well may butcher technical terms, which
Sure.
I learned a long time ago on Google's website.
Sure.
So Google's whole thing is they talk about, like, I think it's a funnel, or where you have like the path to purchasing, and they talk about the different steps.
Oh, sure, yeah, on the,
Yeah,
like,
but-
on the App Store, or
Yeah,
Android
on the App
for
Store, and
yeah.
I think pretty much on anything.
Yeah.
But the thing is, I could be mistaken about this. I don't think that Google Analytics allows you to like identify personally individual people. Do you have like a wall in between like the Google Analytics for the website, and then also say like the mobile games or even some other device where somehow I can show that this person went to Steve?
Sure.
Like, do you have?
yeah.
Is that wall there? Or?
So there's a broader answer to this, and then a more specific one, right? So from a Google standpoint, privacy is our number one concern in all cases, right? So which is to say, you know, and that's everything from like protecting your search history to your Gmail account to what you did in the Android store to, you know, what you're trying to develop to the people that are browsing the Android store, right? So we always have to be very careful, and as a matter of fact, there's a lot of thought that goes into who sees what when they see it, that sort of stuff. Even on like the ad side, you know, you think like, you know, you think if you buy an ad, you just get like, you know, you get tons of data, but you think you get all this like your personal data, and you actually don't, right? And you're sort of experiencing the exact same thing where you see these firewalls in, or this data that is randomized such that you don't know that. What we can do is, when our customer becomes your customer, we have the ability to link that data set so that you can follow that transaction. Okay?
So in other words, if I had, like, let's say, I was doing some sort of like A/B testing or something like that, or somebody would purchase a project and then, not a project, but a product, then I would be able to tell if they purchased the product, I'd be able to look at like the search history or certain things there and be able to make that connection, or am I misreading you?
Slightly misreading, right? Like, just because you buy something on the App Store doesn't open the floodgates of personal data, right? So, but there are some things that you get with that. And if you want to ping me like next week or something over email, there's some things that there's on the API documentation you can see what you get, right? And I mean it's public, you don't really need me, but if you need my guidance to get there, you know, be more involved.
In terms of the analyzed data, for example, we have Facebook Analytics, Google Analytics, and then our own analytics, and sometimes it's difficult to track the path of the data in several contexts.
Right.
Do you have like tools for analyze data and draw from our own database data to mix
Yes.
it to the Google
Yeah, we do.
Analytics?
What you're really talking about is a ETL process, or extract, transform, and load. And you can do that within any big data tool that exists within GCP. Like for example, Apache Spark or Apache Beam, okay, either managed or unmanaged. What we also have is a tool that applies a GUI to that process, where it's called data prep, where you can bring in various data sources, get a visual of what they look like, and then apply simple rules to how you want to transform that data for analysis, right? So, you know, common things in data prep are just like bringing columns around that you know are connected, or taking out anomalies or outliers or things like that, and it's very easy to use. So there's, so in summary, right, there's like 3 ways on a Google standpoint you could do that. Okay. Do you have a question there?
Yeah, we are using GameSpark's backend
Okay.
as a service, and currently they have an amount of analytics, but we're cobbling it together, kind of like what this gentleman said,
Right.
Is there an existing connection to GameSparks to pull the data down into?
I don't know that
Okay.
for 100%,
Okay.
but we could look into it for you. Here's the sort of the bottom line though, is anywhere we can like, you just get a spreadsheet, right, or a CSV file, or even unstructured data. Once you get that into like a Google Cloud storage, or stream it into Google Cloud storage, like a Kafka bus or PubSub bus or something like that, then we can go through that ETL process and do analysis on it from there. So,
Thank you.
all right, so now I think I have a new problem, which is really good conversation, guys, and I appreciate it, but I only have 2 left. I only have 2 left, unless somebody wants my hat or keys to my truck, or
Truck.
truck it is, right? We'll figure it out. Maybe we'll have a joust or arm wrestling match. Good. I really appreciate the conversation. Okay. Okay. So moving on from here, right? So everything thus far has been really high level, right? So now we get into like how do we actually do this and how do we build the pipelines, which is your question in that, right? And we think about this in 4 stages. The first stage is obviously, again, building out that data lake and capturing all this data. So, I already said this, but as a review, this is, event data, game data, log data, app store data, social media data, whatever the case may be, right? Then it becomes a storage option. And, well, I won't get into the GCP statistics, or not statistics, but spot yet, but we store. And then we go through a process standpoint and then a visualization step, right? So, what we sort of think about, well, we think about it all, right? Okay, so, and then that's represented within this pipeline. So, again, this is maybe like one level lower, but this is how we start to build out an analytical pipeline, right? So we say, take in the data somehow, and we've got a couple of different ways to do that. Store it, do some compute on it, and then report on it, right? And from a GCP standpoint or a Google standpoint, we have abilities to do this through a couple different tools. So ingesting the data, right? This could be, what we sort of talked about, which is this idea of log data. So this is data that you're just going to move onto a GCP storage bucket, or if you, as a matter of fact, if your game runs on GCP, it's just a matter of storing it there. Or in the event of real time, so always think about data processing. I gotta get out of it. Always think about data processing as one or we're either doing it in streaming or we're doing it in batch, right? So this bottom part is batch, right? This is log data. This is data that gets dumped like every hour or every day, something like that. And then we have stream data. This is stuff that's happening in real time. So, if all sorts of great examples of stream data, but this could be like, live game interactions, or if there's matches or something like this, right? And when we get this data, we typically try to do this in what's considered an asynchronous messaging bus, which is in the open source world Kafka, if you're familiar with that, okay? And the Google Compute Platform, we have a managed service of messaging bus called PubSub. Great product, poorly named, right? Very obvious, but poorly named, right? And what PubSub does is it says, okay, let me ingest these messages, and what's important is guaranteed delivery. And it does that in a fan-out sort of fashion, right? So you may look at some of this data that comes in and say, okay, I want it to go to X, Y, and Z. PubSub will say, okay, I'll make sure it gets to X, Y, and Z, right? And the most appropriate way to think about PubSub is that it's just a series of APIs that you write to. You build your software and say, I'm going to write to this PubSub topic is the way it goes, and then you have subscribers of that topic, right? Asynchronous messaging goes. From there, we go into the data processing, right? And this is the ETL phase, or extract, transform, and load phase that I talked about earlier. And there's different words for this in the industry, like data massaging or data wrangling or things like that. But the point is here is that we're taking this data and we're transforming it into something that I can use, that I can ask questions of. And so then you may ask, like, well, why do I have to transform the data? Well, a lot of times it's connecting columns, right? If you have all those diverse data sources we talked about earlier, it's taking columns 1 and 2 from this data source and columns 1 and 2 from that data source and making a 4-column table or whatever the case is, or doing some of the things I talked about earlier, like scrubbing, taking out outliers, anomalies, things like that, okay? And from a Google standpoint, we sort of talked about we've got a couple different ways to do this. From a managed service standpoint, you can do this within Spark, Apache, open source Spark. You can do this within the relatively new player in the market, which is called Apache Beam or Data Flow, which is sort of unique because it does batch and stream in a single API. Or you can use the data prep tool that I talked about a little bit earlier. Then from there, you move into an awesome tool. I mean, like I get it, you don't trust me, right? I wouldn't trust them either, right? But BigQuery is awesome, okay? And the reason BigQuery is so awesome is that it allows you to ask those questions of the data without any heavy lifting, as a matter of fact. So, do I put a slide again? I'll come back to this in a little bit. Yeah, I did. Okay, good. So again, BigQuery allows you to ask those questions of the data, and you do so without any big heavy lifting or having to understand all these technical pieces. And you ask all these questions in SQL language, right? So it's not a specialized language like Spark or a Beam or any of these or other tools that are out there in the world. You just ask it things in SQL, and because of that, it makes it very easy to use. The other key thing about BigQuery is that you can think of it as two separate pieces. There's a storage component and there's a query component. And the folks in the room that have experimented with big data or data analytics in the past, I should say, understand that usually we tie storage and compute together, and that's what makes it expensive, right? So with BigQuery, you can separate the data from the compute, and it makes it very cost effective, right? Data storage is cheap, analysis is much more expensive, so I only do analysis on the data I want when I want to actually get those data sources. So I have prepared a small demo for BigQuery because, again, I think it's awesome. Just a quick tour here, right? So over on the side of the screen is all of the Google public and free data sources that are available. So one of the other really cool things we do is we collect all these data for various groups and offer it to you for free. And then we also have a number of commercial data providers like like weather or all sorts of stuff, right? I can't think of any examples, right? So one of the free data sources that are available is stuff from Stack Overflow. So if you look at Stack Overflow and you just look at this one table, this is 68.7 gig with almost 1 million rows in it, or 100,000 rows, or 100 million rows. Yeah, that's what it is. And then, like I said, the trick is here is we want to ask questions of this data, and we want to do so in a relatively easy way. So, like any cooking show, I've already baked the cake in terms of the save query. So this is actually a fun one, right? So in this case, in this case, we're saying we're looking at the Wikipedia public data source, and we say, which articles are vandalized the most, right? Pretty interesting. Any guesses? Points for top 10? I don't have anything else to give you.
Politician names, I would imagine.
Yeah, it was up there. Yeah.
JFK assassination.
Yeah, good one. Let's try and find out, right? So here we go, right? So it gave us the answer, but it cheated. Here we go. So here we are. We're looking at this data source, and what did it tell us, right? It said it processed 20 gigs of data. It took 4.8 seconds to process that. Again, through this relatively simple SQL language, and what's that? Yeah, my normally relatively attractive Mac resolution is turned into this. All right, so some interesting answers, right? So 10 points to the man up front, right? you guessed right in terms of a politician having the highest vandalism count, but also a RuneScape, which that was interesting. So, anything else in here? Led Zeppelin. Who vandalizes Led Zeppelin's Wikipedia? Pink Floyd. All right, so some other ones, right? So you don't believe me yet, I get it, right? So let's do another one, right? So here you go. This one's a little more complex, so it's perfect, right? So I'm sure everyone's familiar with Stack Stack Overflow. I know I certainly am. You know, which of the 10 gold badges are easiest to earn, right? So again, this is all written in SQL language, which hopefully you're maybe a little bit familiar with. It's a little bit more complex. We run a query here. We cheat it again. It's using cache results. That's why it's saying it's cheating. The guys that pay my GCP bill would like me to use cache results, but they're not here. So, okay, so,
Could hide options up, probably,
where?
right to the right of the query, that.
Hey, whose tool is this? I'm messing with it. All right, so which one did we do, right? Oh, okay, so 10 easiest badges, right? So we did the, oh, see, now I lost the data. But it's a lot of data that processed in a short period of time. That's the magic, okay? And then there's our answer, right? So again, right, BigQuery is all about asking those questions, exploring that data. So what, you know, so, right, so in review, what did I do? I took this data in, I ran it through some sort of transformation process, I dumped it into BigQuery in terms of these tables, and then I query against the tables. And you know, this is the case where you see, you know, just a ton of data. You know, it's capable of handling, you know, really quite a lot of data. And again, right, it's, you know, don't take my word for it. You know, this has been proven within the gaming industry. So these guys are on record, you know, saying they're using BigQuery, so I'm comfortable repeating it. You know, this is their words, right? And to the point where it may have led to more downloads. You know, as a as a person that understands statistics, I really can't say cause and effect, but okay. So now let's talk about storage a little bit. We talked about this a little bit, but I wanted to make sure that the group understood all the options that we have within Google. So over at the beginning over here is on my right is you know, memory store sort of service that's in beta. We also have managed SQL services for MySQL and Postgres. If you're looking for that sort of tool set. We have something called Cloud Spanner, which is, in my opinion, one notch less cool than BigQuery. But what a Cloud Spanner is it's a globally consistent SQL-based data store, and it's very popular if you run a worldwide service and you need globally consistent data and you want low latency wherever that user connects. Okay, you put this data into Cloud Spanner, and it uses that GCP infrastructure that we talked about earlier to distribute and replicate that data all across the world. Right, very, very cool. We have Cloud Data Store, NoSQL service, Bigtable, which is managed HBase, if you're familiar with that. Regular old object storage in terms of cloud storage, and then finally the data warehouse in BigQuery that we talked about earlier. Okay. Any questions on any of that stuff? I get it. You know a lot of things to give away. It's fine. Okay. So I left this in here because I'm an open source guy, and I like open source and I like open systems. So what I'm really showing you here is almost the exact same thing, right, in terms of that pipeline, that data pipeline, of how we would start to, you know, get the answers to those questions you're searching for within the data set. And what I'm saying here is that you're welcome to use our tools, you're welcome to use our managed services tools. We think there's advantages to using those managed services tools, but at any spot within the pipeline or for the entire pipeline, if you'd rather not, if you know, for example, if you want to run your own Spark cluster or, you know, Kafka bus or HBase or whatever the case is, you know, we fully support those things as well. Okay, and as a matter of fact, you know, there's a lot of great success stories and a lot of documentation around how to do that. Okay, so sort of wrapping up here, I wanted to talk a little bit about machine learning, which is where most of my work and intellectual interest is in. So when you think about ML, machine learning, it's often appropriate to think about it as maybe the last step of that pipeline that I talked about earlier. So, you know, a lot of those examples that I gave, success with big data, the next thing they're exploring is machine learning. And what do we get on machine learning? Well, we get the ability to make predictions, right? Statistically accurate predictions on what could happen given a data set. So we work on, we do something called training, right? So you give a machine learning model, you give a machine learning model a bunch of training data, and you say, hey, here's 10,000 examples, or better yet, 10 million examples of what happened in the past, given a series of features or attributes for that interaction. And then when I give that model, I give that machine learning model a new piece of data, it'll come back and say, well, here's what I predict, right? Here's what I predict will happen. That's called supervised machine learning. And the advantages of this are, you know, there's just all sorts of applications for this, everything from self-driving cars to, you know, better villains in video games, in my opinion, right? There's all sorts of really cool things that we can do with machine learning. So, so then again, the question comes in, well, you know, what is it, right? How do I get started? So Google released something called TensorFlow into the open source community in 2015, it could be 2014, please don't quote me on that. And TensorFlow is a way to do machine learning in a relatively new way, which is called building neural networks, or neural nets, as they're sometimes referred to. And neural nets are actually wicked cool. You're seeing academic programs spawn up around them all over the place. I think MIT and Harvard both have specific programs. I could be wrong on that too, but a bunch of academic programs spun up specifically around neural nets. But what's neat about them is that they're machine learning models that are designed to mimic the human brain. So you have all these neurons, right? And then all these neurons are connected to each other. And then, you know, when you learn something either through a computer or in the human brain, they light up and they give values back and back propagation and feedback and all that kind of stuff, right? So TensorFlow is, you know, so that was a lot of words, right? So let me repeat that. TensorFlow is a way, it's a tool set to build out neural nets within a computer, okay? And again, it's an open source software written by and released by Google. And it is by far, at this point, just based on, you know, downloads and Stack Overflow and, you know, some of the other ways you measure this, it is by far the most popular machine learning library available today, especially for building neural nets. So, one other neat thing about TensorFlow is, so tensor in mathematics, another word for vector, some of you may recall, right? So what that said, and then the way you build these models is that it's these tensors that flow into these activations. That's where the name comes from, as a matter of fact. And what that means is that it doesn't necessarily work well on general purpose CPU, right? Reduced instruction set CPU. So where we see a lot of advantages in TensorFlow, especially in the training side, is when we wrap in GPUs into that, or better yet, Google has something called TPUs, or TensorFlow processing units, that are even much faster than what GPUs do. And the big advantage of TPUs is that they are a you call it a complex instruction set from a processor standpoint, and they do two things. They do matrix multiplication, or tensor, another word for that is tensor multiplication, and they do these activation functions. So is it 0 or 1? Just think of it that way, as an activation function, right? So anyway, TensorFlow rocks, very cool. Like I said, it's where most of my career and academics interests sit these days. And from a Google standpoint, we have all sorts of ways that you can run TensorFlow. So you can just spin up a couple of Linux servers on the infrastructure side and run your own, or as you would expect, we also have managed TensorFlow. So what's nice about this is that you build the model, or we help you build a model in some cases, and then you apply your model to a managed TensorFlow instance, and you get your answer. You don't have to deal with any of the complexities of running TensorFlow, which can sometimes be quite great. And then if you want to bring it one step further even from that, we offer pre-trained models as APIs, right? So what these pre-trained models are is that this is a way that you can consume TensorFlow without building a model, without all the complexity in the data science stuff. You can just say, I just want to hit this API and have it tell me something. So we have APIs that do image, it's called vision, right? It does image recognition. You can tell it to pick out objects in the vision or in the picture, or faces, or really anything within the picture itself. We can look at that picture and then tell you what's in it. We can do that with video. We can do that with sound. We can do that with speech. We've got a really, if you've ever messed around, I'm sure some of you have messed around with NLP, natural language processing. We can actually do that with NLP and do classification, vague word sort of stuff within the language API. Again, it's all powered by TensorFlow, and the beautiful thing is it's very, very easy to use, and it's actually really inexpensive too. So I actually encourage everybody to just go play around with it. You get like 1,000 free calls per API per month or something like that, and we've seen some pretty amazing things from folks staying under the free tier of some of the machine learning APIs. So with that, I'm almost done. I guess just a final comment is this. So from a gaming standpoint, this is an industry that we are very committed to. We actually have our own conferences, as maybe some of you guys know, around gaming. We've got a dedicated group of developers for gaming. We've got marketing and sales folks that focus in on this industry. And hopefully, like you saw in some of the previous slides, somewhere that we've been very successful in the past with other customers. So I'm very interested in learning about what you're doing and figuring out if Google can help. So I'll be here for the rest of the day and very interested in any questions or conversations you'd like to have. So with that, I thank you.